So whether you're new to calculus or just looking for a refresher on differentiation, there are a few properties and rules that you're going to need to know to take the most basic of derivatives. And starting with those properties, the easiest is, what do I do if I need to take the derivative of a constant, right? So let's say we're taking the derivative of 3. Now this is just one notation of the derivative, d dx. That means the derivative of 3 with respect to x. And there's a few other notations, but we'll get to those after this. So the derivative of any constant, as it always holds, is going to be equal to 0. That is a C, okay, 0. So if we're taking the derivative of, let's say, 1/3 with respect to x, you know what, let's just make it negative for fun. That's going to be 0. If we're taking the derivative of, let's say, 5,000, it's always going to be 0. So now you know, if somebody asks for the derivative of any constant, it's going to be 0. Now, what if somebody says, hey, I've got this line, right, and it's y is equal to 3x, and I want you to find dy dx. Now, this is one of our new notations. That means the derivative of y with respect to x. So in this case, we have that y is equal to 3x. It's just a constant and a multiple. And in this case, the derivative is always going to be equal to the constant in front of our variable x. So dy dx is just equal to 3. Likewise, if we had, here we'll use the same numbers as before. Let's say y, instead of being equal to 3x, was, let's say that it's equal to 1/3 x, right? So we'll say y is equal to, we'll make it a negative 1/3. Then dy dx is going to be equal to negative 1/3. And like if we had y is equal to 5,000x, then dy dx would be equal to 5,000. So now we've got two very simple properties out of the way. If it's just a constant, it's 0. And if we have a constant in the variable, then it's just going to be the constant that's in front of the variable. So very simple stuff to keep in mind. Now the next thing to know is when we are taking the derivative of two things that are being added together or subtracted. So let's say we have y is equal to 3x plus 5, and we're asked to find dy dx. All we'll do is take the derivative of 3x and then add the derivative of 5. So we know now that 3x is 3, the derivative, and we know that the derivative of any constant is 0, so 5 is just going to be equal to 0. So we have dy dx is equal to 3. The same thing holds if we're doing subtraction. So let's say we have y is equal to, let's say, negative 7 minus 14x. Sure. Find dy dx. Okay, well first let's take the derivative of negative 7. We know that that's just going to be equal to 0. And then we have minus 14x. So 14x, the derivative of that is just a constant 14 in front. So we'll have 0 minus 14, and we get negative 14. So now we've got very basic properties out of the way. The derivative of any constant is 0. The derivative of a constant and a multiple is just going to be the constant. And then we can add and subtract. We can distribute kind of the derivative to each parts of the addition or subtraction. So now we'll start getting into the rules. And the first of these rules, very simple. It is just the power rule. So let me clear the screen so we can start fresh. We have power rule. And this is a very basic rule too. So when we're doing the power rule, right? Let's write an arbitrary definition that we can start with. Say we have some variable x raised to power n. Now in this case, x is our variable and n can be a constant. Say it could be 2, 3, negative 5, a million, any number, right? The derivative of this function here, let's not do that. Let's say we have y is equal to x to the n, then dy dx is going to be equal to n times x to the n minus 1 power. Now you might be looking at that stuff and think, okay, well that doesn't make any sense. But it will if we just put some numbers into practice, right? So here's what we'll do. We'll say y is equal to x to the 5th power. Now, assuming you've never done the derivative before and you have no idea how to do this, we can just use our arbitrary definition that we have labeled right here to figure out what the answer is, right? So we know that x is x, and in this case, 5 is our nth power, right? So the derivative is equal to n, okay, so in this case it's 5, times x to the n minus 1 power. We know that n is 5, 5 minus 1 is 4, so that's our derivative. Now as you'll see, all we did is we took the original power 5 from here, moved it to the front, and then lowered the power by 1. So let's say we have y is equal to x to the negative 6th. Here's what we're going to do. We're going to say, all right, we need to find dy dx. We're going to move that power to the front, so negative 6x. And then what is negative 6 minus 1? Well, that's negative 7. And there's our answer. Now, what do we do if we have a constant in front of our variable that's raised to a power? Say we have y is equal to 3x squared. How do we do this? Well, all we're going to do is we're going to move that power to the front like we have been, 2. And that constant that's there, 3, is going to just stay where it is. It's going to continue being multiplied by everything we have. So we have 2 times 3x. And then we're going to lower the power by 1 like we have before. So 2 minus 1 is 1. And then this can be simplified to 2 times 3x is 6x. Let's do another example of that constant in front of our variable with a power just to really cement it. Let's say we have y is equal to negative 7 times x to the 4th. We need to find dy dx. Then that's going to be equal to 4 times negative 7 x to the 3rd power, which is negative 28 times x to the 3rd power. So the power rule is very simple, especially when you practice it over and over again, and that's the key to understanding and cementing these rules into your mind, is just practicing them with any made-up numbers you want. It becomes very easy to do. And so now that we have the power rule, we're going to go into the product rule. Okay, product rule. So just like the power rule, we're going to start with an arbitrary definition first, and then plug in some numbers to make sense of it, right? So let's say we have y is equal to u times v, and u and v they could be constants. Let's say they're just the variable x. It could be 3x. They're going to be the things that we're taking the derivative with respect to x to, right? So we have two things multiplied by each other, right? And we want to find dy dx. That is going to be equal to, and here's a new notation that I'm going to use so I don't have to repeatedly write ddx or dy dx. Prime. That little apostrophe right there, we call it prime, and that just means the derivative of. So we'll have u prime times v, which is the derivative of u times v, plus u times v prime. Now, like we did before, let's make some sense of this with real numbers if this isn't clicking. So what if we have y is equal to 3x plus 5 times, let's say 7x plus 2, sure. We want to take the derivative of this. Now we could just factor this whole expression, multiply everything by itself, and then we could probably just apply the power rule and the constant rule and the constant multiple rule that we've learned already. But we want to do this because it'll be faster for us. So how can we start this, right? Okay, well, clearly we need to know what u, v, u prime, and v prime are, right? So let's start by defining those, right? We can say that u is 3x plus 5 in this situation, right? And let's say that v is equal to 7x plus 2. So we have the two things that are being multiplied by each other. Now we need u prime and v prime. And as we've established, these are just the derivatives of u and v, right? So let's do that. The derivative of 3x plus 5 is the derivative of u. And by now, we should know that this is a very easy thing to do. The derivative of 3x is just 3, and 5 is 0, so the derivative of u is just 3. The same with v prime, right? What's the derivative of 7x plus 2? That's just going to be equal to 7. Okay, so now we have u, v, u prime, and v prime. Let's just plug this into the definition that we have right here, right? So we have dy dx is equal to u prime, all right, that's 3, times v. Okay, so that's this whole expression, 7x plus 2. And then we have plus u, All right, well, that's that whole expression 3x plus 5 times v prime. All right, well, that's 7. And that's our derivative. Now, obviously, you can multiply 3 and, like, distribute the 3 and then distribute the 7 to each part of this expression and then add it all together. We're not going to waste time doing that because we're not here to learn how to add and multiply. We're here to learn how to take the derivative. And it's that simple. It's as simple as just knowing this very useful definition right over here, right here. And being able to break the problem down into, okay, what's u, v, u prime, and v prime? So if you've got that down, we can move on to doing the quotient rule, which is going to be as we did multiplication before, now we're doing division, right? So quotient rule. I missed the dot on the I, but that's fine. So what if we have y is equal to some u divided by some v? We need to find dy dx. Now this is actually going to be similar to our product rule, right? And here's how. We're going to have u prime, so the derivative of the numerator, times v minus u v prime. Now, as you can see, that is identical to the product rule. The only difference is this little subtraction sign right there. For product rule, we're adding. For quotient rule, we're subtracting. But we're not done right here. We're going to take that whole thing and divide it by the denominator v squared. Now, adding that denominator might have seemed like it just complicated everything, but it's really not, because again, we're just going to look for our u's, our v's, take the derivative of both of those, and then apply it to this arbitrary definition we have here. So let's say let's work with numbers now. We have y is equal to, and you're going to see me repeating a lot of the same numbers, 3x plus 5, that's come up before. And let's divide this all by 4x squared. That's probably not going to be fun to work with, but it's okay. So let's start by, well, we know what defining our numerator and our denominator. So we know u is 3x plus 5, and v is 4x squared. Now we just need u prime and v prime, and we'll have all the components we need to solve this derivative, right? So the derivative of 3x plus 5 we know is just 3 by this point, and 4x squared, this kind of looks like ux squared, but you get it. 4x squared, well, from the power rule, we know that that's going to be 2 times 4x to the first power, which is just 8x. See how if we know these basic building blocks that we learned in like the first minute or two of the video, how it becomes very easy to do these more complicated ones? So we have u, v, u prime, and v prime. Let's plug these now defined variables into our definition that we came up with, right? So, okay, we have to find dy dx. Well, that's going to be u prime times v. Okay, so that's 3 times 4x squared minus u times v prime. So that's, okay, we have u is 3x plus 5. V prime, what did we say v prime is? We said v prime is 8x. And now we just have to divide that all by v squared. Okay, so that's v is 4x squared. And we just square that. Now, as you can see, we found a derivative, and that wasn't hard. I think the hardest part of all this is having to multiply everything out, subtract, add, divide, all that stuff. But again, we're not here to learn how to do that. We're here to learn how to take the derivative. So with that, we can move on to the chain rule. And this is usually where people tap out when they're starting calculus and they're like, okay, the quotient rule was kind of difficult, but then they get to the chain rule and they're like, all right, well, I'll just clock out right here. So the chain rule, why people might find it so difficult is because it deals with functions inside functions. Now, hopefully, if you're learning how to take the derivative, you've taken pre-calc or literally any other math before now and have dealt with something like this, f of x and g of x, right? And you've hopefully dealt with this particular case, f of g of x. You may have called this fog in one of your classes, or if you were doing g of f of x, you may have called it goff. And it simply means that if we have, let's say, f of x, here, I'll go and explain this real quick. Let's say f of x is equal to x squared, and g of x is equal to 3x. Then anywhere there's an x in the f of x function, we'll plug in what g of x is equal to. So f of g of x is equal to 3x squared. There's your little crash course for fog and Goff, but now we're going to get back into doing the derivative, right? So, what if we need to take the derivative of something like this? Would it say y is equal to f of g of x, and we need dy dx? Here's what we're going to do. We're going to start by taking the derivative of that interior function g, right? So we'll call that g prime of x. And we're going to multiply it by the derivative of the exterior function f, so f prime of g of x. And this is where people stop. They see this and they're like, okay, that makes literally no sense, but we're going to make it make sense, right? So let's say, what can we do? Okay, let's say we have y is equal to, let's switch up the numbers we're using. We're not going to use 3x plus 5 anymore. We'll use 7x minus 2. Ooh. To the 4th power. Okay. And it's not as clear as before when we were doing u, v, u prime, v prime, finding those variables and just plugging them in. It's not as clear as this because we're looking for f of x, g of x, g prime of x, f prime of g of x, all this weird stuff. So let's try and break it down real quick. So clearly we have this interior function right here. And before we define g as our interior function, so we'll say, okay, we're not sure what f of x is equal to yet, right? But we know that g of x is equal to 7x minus 2. And we don't know what f of x is, so we're not going to find what f prime of x is. And we know what g of x is, so we can find what g prime of x is. And we know now that that's just going to be 7. Very easy to do the derivative of 7x minus 2. So what could be f of x? We still have this power here, right? We have this power that we're raising g to. So maybe, perhaps, the base function f of x could just be x to the 4th power. And that would make sense, right? Because if y is supposed to be equal, if y, like this thing right here, is supposed to be equal to f of g of x, right? And f of x is x to the 4th, and we plug in g of x anywhere there's an x in the f function, then this is going to be equal to, here, let's keep writing. Let's say f of x is x to the 4th, then f of g of x is going to be equal to g of x is 7x minus 2, so 7x minus 2 to the 4th. And as you can see, that's exactly the same as what we have here. And let me make it clear that this right here is just equal to f of x, in case this wasn't confusing enough. So our base function f, we've established, is x to the 4th. And so that means f prime of x is going to be 4x cubed, because we know the power rule. So now that we have everything, let's go back to our arbitrary definition, the one that we have right here, and start plugging in some numbers, right? So g prime of x, we have dy dx is equal to 7, that's our g prime of x, times f prime of g of x. So we know that f prime of x is 4x cubed, right? And now, since it's f prime of g of x, we want to plug in g of x anywhere there's an x in our function, right? So that's what we're going to do here. Let me just erase some of this now. So instead of x cubed, what we'll have is our function g of x, 7x minus 2, and cube that instead. And now we have found our derivative, and we can just multiply this just to make it look a little nicer. And that's our derivative. Now, I know I said a lot of g's and f's and x right now that make this confusing, and it is confusing. But the concept that you want to walk away from this understanding is that we started with, here, where are we? Where's our beginning? We start with a interior function and an exterior function. We have to be able to identify those and say, okay, I want the derivative of the interior times the derivative of the exterior, that's what this means, with the interior still intact. Now, this is going to come into play when you learn trig functions and you're doing the derivative of trig functions. I won't go over that in this video, but here, let's do a quick example. So let's assume that you're already familiar with what the derivative of sine of x is equal to, right? And I'll tell you right now, that's cosine of x. Now, what if you need to find here. Sine of x is not equal to cosine x. Let's just say that ddx of sine of x is equal to cosine x. So now what if somebody's like, all right, what's the derivative of sine of 3x? It would be wrong to say that it's cosine of 3x, because this is where our chain rule comes into play. Instead, the derivative of sine of 3x is going to be equal to the derivative of that interior function, so 3x, that's going to be equal to 3, times the derivative of the exterior, so that's cosine, with the interior still intact. And now, if you have hopefully understood all the rules and properties we've gone over in this video, you now know how to take the derivative of a basic function.